Hello, brilliant minds, your friendly guide to the world of coding and machine learning here. We're journeying together through the Machine Learning for Dummies series, and we've arrived at an exciting destination, Module 2. This module is all about supervised learning, a key concept that includes two main components, regression and classification. We'll be exploring how these techniques help machines learn from data and make predictions. So, are you ready to delve into the fascinating world of supervised learning? Buckle up! So what is supervised learning, you might ask? Well, let's unravel this intriguing concept together. Imagine you're teaching a child how to distinguish between different fruits. You'd show them an apple and say, "This is an apple." You'd repeat the process with other fruits until they can recognize them on their own. That's pretty much how supervised learning works. In the realm of machine learning, supervised learning is a method where we train an algorithm using labeled data. Think of it as a teacher-student interaction. The teacher in this case is the dataset with known answers, also known as labels, and the student is the algorithm we're training. The goal? To make the algorithm smart enough to make accurate predictions or decisions without being explicitly programmed to do so. Now, there are two main types of supervised learning tasks: regression and classification. Let's dive a little deeper into these. In regression, we're trying to predict a continuous outcome. It's like trying to guess the price of a house based on its features, like the number of rooms, the size of the yard, or the neighborhood it's in. The output here is a continuous value, the estimated price of the house. On the other hand, classification is about assigning data to categories. Picture a system that sifts through your emails and identifies which ones are spam or not. Here, the output is a category, spam or not spam. Whether we're talking about regression or classification, the magic of supervised learning lies in its ability to learn from examples and apply this learning to new, unseen data. It's like teaching a child to recognize apples, and then they can identify apples in a fruit salad they've never seen before. In essence, supervised learning allows computers to learn from examples and make predictions on their own. Are you ready to delve deeper into this fascinating world? Let's move on to visualize how regression and classification work in the next scene. A picture is worth 1,000 words, they say, so let's paint a picture of regression and classification. Imagine regression as a treasure hunt. We're trying to find a hidden treasure, a continuous value such as a house price based on certain clues or features like number of rooms, location, and age of the house. The more accurate our prediction, the closer we get to the treasure. On the other hand, classification is like sorting a pile of mixed objects into distinct categories. The objects are the data points, and the categories could be anything from spam or not spam for emails to cat or dog for images. The goal is to correctly identify which category each object belongs to. As you can see, regression and classification serve different purposes, but are both vital in the field of machine learning. So, where can we see supervised learning in action? Well, let's dive into the fascinating world of real-life applications of supervised learning. Let's start with regression. Have you ever wondered how financial analysts predict future stock prices? They use regression models. By feeding historical data into these models, they are able to forecast future trends. This allows investors to make informed decisions, enhancing their chances of making a profit. Now, let's move to classification. It's used in email filtering systems to detect spam. By training on a dataset of emails labeled as spam or not spam, the system learns to classify new emails into these categories. So, when that prince from a far-off land promises you a fortune, the system knows it's a scam and promptly moves it to your spam folder. Ever marveled at how social media platforms automatically tag you in photos? That's image recognition, a classification task. The algorithm is trained on a vast amount of images, learning to identify and categorize objects, and yes, even your face. What about the recommendation systems on your favorite shopping or streaming sites? They also use supervised learning. By analyzing your past behavior and preferences, the system can classify and recommend products or shows you might like. These examples show how pervasive and influential supervised learning is in our daily lives. From making profitable investments to avoiding spam, from social media interactions to personalized recommendations, supervised learning is truly transforming the way we live and interact with technology. Now let's get our hands dirty with some key concepts. In the pulsating world of supervised learning, there are some terms that you'll come across time and again. These terms, features, labels, training data, and testing data, are the building blocks of machine learning. Features are the variables or attributes that our machine learning model uses to make predictions. If we consider our house price prediction example, features could include the size of the house, the number of rooms, or the location. Labels, on the other hand, are what we're trying to predict. In the house price prediction example, the label would be the actual price of the house. Now, let's talk about training data and testing data. As the name suggests, training data is used to train our machine learning model. It is the data that our model learns from. The model uses this data to identify patterns and relationships between the features and the label. Testing data, however, is used to evaluate the performance of our model. It's like the final exam for our model. This data is separate from the training data and gives us a good indication of how our model will perform on unseen real-world data. Now, you may be wondering, how does our model learn from the data? Well, this is where algorithms come into play. For regression tasks, we could use algorithms like linear regression or decision trees. These algorithms try to find the best fit line or rules that can accurately predict the continuous label from the given features. For classification tasks, we could use algorithms like logistic regression or support vector machines. These algorithms try to find boundaries that can accurately classify the data into different categories. Remember, the choice of algorithm depends on the type of task at hand, the nature of the data, and the specific requirements of the problem. Now, understanding these concepts is crucial as they form the backbone of any supervised learning task. It's time to put our knowledge into practice. Let's dive into a simple regression problem. Imagine we have a data set of house prices. Each house has certain features: the number of bedrooms, the size in square feet, the neighborhood it's in, and we want to predict the price of a house based on these features. This is our regression problem. First, we need to understand our data. It's like getting to know the pieces of a puzzle before putting it together. We look at the features, the labels, which in this case is the price of the house, and the relationship between them. Next, we split our data into two parts: the training data and the testing data. The training data is like our practice ground. It's where our algorithm learns about the relationship between the features and the labels. The testing data, on the other hand, is used to check how well our model has learned. Now it's time to choose an algorithm. For simplicity, let's use linear regression. This algorithm tries to find a line that best fits the relationship between our features and labels in the training data. Picture a scatterplot of data points, and our algorithm is trying to draw a straight line that is as close as possible to all these points. Once we've chosen our algorithm, we train our model. This is where the magic happens. Our model learns from the training data. It's like a student studying for an exam, absorbing all the information and learning the patterns. After training, our model is ready to make predictions. We give it the features of a house it has never seen before, and it predicts the price. But how do we know if our prediction is good? We compare our prediction with the actual price in the testing data. If it's close, we pat ourselves on the back. If it's not, we go back, tweak our model, and try again. Remember, machine learning is an iterative process. Lastly, we evaluate our model. We use certain metrics, like mean absolute error or root mean squared error, to measure how far off our predictions are from the actual prices. This gives us a quantitative measure of how good our model is. And voila! We just trained our first machine learning model. The beauty of machine learning is that the same process applies no matter how complex the problem is. So, take this knowledge, play around with it, apply it to different data sets, and watch as the world of machine learning unfolds before your eyes. So, what's next on our learning journey? Well, it's time to roll up our sleeves and dig a bit deeper. Our next module will take us further into the vast and fascinating world of supervised learning. We'll explore more advanced aspects, unraveling the intricacies of algorithms like decision trees and neural networks. We'll also dive into practical applications, working with real-world datasets. So brace yourselves for an exciting ride. Stay tuned for our next module where we'll dive deeper into the world of supervised learning. To wrap things up, we've delved into the fascinating world of supervised learning, unraveled regression and classification, and decoded key concepts. Now it's your turn to practice and bring these concepts to life. Remember, practice makes perfect. Until next time, keep learning and exploring. Before we wrap things up completely, we would love to extend an invitation for you to join our community here at DemystifyTech. If you found this video helpful and want to continue exploring the exciting world of machine learning and technology, hit that subscribe button. This way, you won't miss any of our upcoming videos. And remember, knowledge shared is knowledge multiplied. So, don't hesitate to share our content with anyone who might benefit from it. Stay curious, stay informed, and keep fueling your passion for learning. See you in the next video.